Hello guys, my name is Arun and welcome to my channel. This is a series of tutorials on Fortran programming. Now in the last program we looked at some formatting specifications for character, and then we looked at arrays, how to define arrays, and then we looked at an example of arrays using the by finding the Fibonacci series, and then we played around with allocatable memory. By played around the arrays with dynamic allocation, and then finally we kind of really annoyed the compiler by testing the limits of what the what the upper limits of integer values can store for each and every byte. Okay, and then we learned about a little about segmentation fault when when the compiler allocates, recrosses beyond. It's trying to access a memory that it does not have any authority or bound within it. Okay, and now in this tutorial we'll be looking a little more. We'll be looking into a little more of formatting, and this time this is more of a read and write formatting. Now all this time we were working with files, and all this time we were reading files, reading values from, not from the compiler, from the user, but we did not read anything from files. Okay, and we did not write any answers in the files, in any paper, in any text file or anything. So in this tutorial we'll see how to write that. If you guys notice, I'm using the same Fibonacci array, Fibonacci series generating program that we used last time, and except that I made a little more modifications here. See what I'm going to do in this tutorial. All the files remain the same, all the things remain the same, except that I have made a little more modifications. The first modification is that I introduced a new array called as C_vals, and then I created a new a type of integer array called as nvals. This is also dynamically allocatable, where the size of it gets determined during the runtime. Okay, and it's also free in dimension. It's also an integer. Okay, and this remains the same. And as usual, I'm just reading the value from the user, printing the content as per this. And in the allocation, I'm allocating fib_vals with n values as before, except that I'm allocating these two along with them. So I'm allocating C_vals and n_vals along with them. Okay, and then this is where the new thing begins. To start writing files or reading files, what we need is we need to make a file and make it somewhat easy to access in the file systems. Now how to do that is, there is this nice little handy function in Fortran called as open. What it does is, this open command helps you to create a file if it is available, if it is not available, or open a file if it's present, and assigns a easy to follow name to it with a number format. Okay, what this program does is that it opens a file creates a file called as fib_val.txt if the file is not available, and allocates assigns a number to it. Like for this, the number is 1. It's given by the term unit, and the file name is given by the term file. Okay, and this value 1 is similar to the 5 for format. It's just an indication, okay, and nothing more of it. And then I create a new format statement with a number label 15. Okay, and this format is such that I initially represent an integer with 3 blocks of spaces, and then 3 spaces. Okay, and then I have 5 spaces separating these two numbers, and then I represent an integer with 25 spaces on the screen or on the print. Okay, and then this is the usual Fibonacci calculation algorithm that we practiced, that we did in the previous program. and what changes I make is in this do loop. Okay, along while I'm printing this do loop value. I'm printing the values of the current value of I and then the Fibonacci value, okay, from the arrays, and with this using this format. And also what I'm doing is that I'm writing these values into the file. How do I write this? Is by this. There's this write statement which helps you to write the values into a file. Now to indicate which file it is, okay, it needs two indications. One, the file in which it is to be written, and the format in which the contents have to be written and extracted. In the future this will be good for extraction also. Now the unit to indicate the file which I am working on right now, I write this term unit equals 1. This signifies that I will be working with this file fib_val.txt. Okay, and then to mention the manner or format in which I should write the contents, okay, I use this fmt variable and assign this to 15. This implies that I'm using this format in writing to write the values. Okay, and to pass to this is kind of like a format setting to write the contents. Now to pass the variables, what I do, I pass I and fib_vals of I. Okay, and now you can just simply write this as write this statement like this: 1,15. Write 1,15. But it's better to write like this because you know exactly what term you're using and what term you're not using. So you know what value each corresponds to. That's it. And then what I'm doing is that see, I opened a file here. Okay, I'm opened a file here. I set a format here. I'm writing the files with the format specified above. Okay, and I have to close the file. Okay, usually you don't necessarily require to close a file. Okay, while end of the program the files get automatically closed. The compiler closes the file. But if you want to access the file contents again in the program, somewhere again in the program, or in some other subprogram that runs simultaneously or something, it's better you close the file. And to close it, what you have to do is write the command close, and then inside it specify the file. To specify the file, you don't have, just like the write command, just specify the unit, and that is sufficient. Once this command is executed, the file gets closed. And what I'm doing right now, okay, now I'll explain you guys why I used c_vals and n_vals here. Okay, what I do is that I'm reopening this file with another unit name 2, so that I do not confuse you guys with one. I don't confuse you guys and all. Okay, I reopen the same file with the unit 2, with the file unit 2. Now what I do is that using the read statement, read also has an internal formatting. Read also has an internal formatting. Now what I'm doing is that I'm reading the file. This command under this for loop reads the file fib_val.txt using this notation unit equals 2, because unit equals 2 is addressing this file, so it's reading that. And in the format, I'm specifying the format to be 15. 15 is nothing but the format we specified to write the file. I'm just reusing the same format here. And if the reading follows this format, it will extract two variables in each and every line, and the first value will be an integer, and that gets stored in n_vals and n_vals of I, and next will be the equivalent Fibonacci term that will get stored in c_vals of I. Now what I do, just to make sure that both of them are right, I extracted them properly, I'm just going to check them out. How do I check them out? In this line, what I'm going to do is that I'm going to print in an unformatted manner. I'm going to print the value of I. So this line will give the value of I. So it will print I equals the value of I, and followed by I minus n. What it will do is it subtracts I and n_vals of I, and it prints the answer, and then it is going to print fib minus fib check, which will be equal to the Fibonacci value that we calculated in here for each and every value of I, and the value that we just extracted in the above line. We'll be using this, and we'll be defining the difference of it. Now if our extraction goes perfectly right, this should yield the value. This should change from 1 to 100, and this value should remain 0 from all the way for all values of I, and this should also remain 0 all the way. Okay, now to check this, what I'm doing is, after this do loop does, I have to deallocate the values. Since I'm allocating the memory here, it's a good practice to deallocate it. Sometimes if you don't deallocate, maybe these values might still be occupying memory and might make other programs that are running simultaneously to fetch memory at other places. If this memory is deallocated, then this memory can be reused by some other programs that are running simultaneously and all. And finally, since we open this file again, you have to close this file using this term. Okay, now hope you guys are able to follow what I've written. Okay, and you guys are okay with my explanation of it. Now let's see. I come here. This is how the result looks like. I just cross-checked it, and if you guys want to have a look at it, this is how it looks like. And now let me just clear this. Okay. Let me just clear this. I know I just confused with stuff. Okay, now I'll compile this program, no issues, and then execute this fib.exe statement. It asks me for the number of terms. I gave it 100, and that's it. It prints all the values of I minus n, and fib check, and all of them are 0. Perfect. And if you guys notice, it prints the Fibonacci values also, and then you get these values also. Now if I just click an ls, I still have this fib underscore val. What I can do is that I can just type genie and then type fib underscore val to open it, and when I open this, I get the same files. Without having any modification. Now open file, when there's just one more comment here. When this open command is used, okay, if the file is absent, it will create the file, and if the file is already present, it will read the file in a read-only mode alone. If a read command is used, this read command is used, then the file will be treated as a read only. But if the write command is used, the file will be appended or overwritten. So when you guys are working with multiple files, transfer and copy, saving files from one file to another, or doing some kind of manipulation of that sort, be a little careful while choosing the units and formatting specifications and all. Okay, and that's all I have for this tutorial. Thank you guys for watching. In the next tutorial, I promise you, I won't sway from my word. Okay, I'll promise you we look into little more of arrays, and then if time permits, I'll give you guys an introduction to functions and subroutines and all. Thank you guys for watching. So see you guys next time.